Hello to everybody. I welcome you all for Power Plant Engineering. My name is Manish Sharma. I am an assistant professor at Mechanical Engineering Department of Bharat Institute of Engineering and Technology. Before we go on to start with Power Plant Engineering, let me share my Google Classroom code with you all so that you can find all my PPTs there. My Google Classroom code is LS9FLL. The classroom name is Final Year A. So these are some of the reference books that I am using. AK Raja, 2006, Power Plant Engineering, US India publication. Then PK Nag, Power Plant Engineering, third edition, Tata McGraw-Hill Publishing Company. Then RK Rajput, a textbook of Power Plant Engineering, fourth edition, Lakshmi Publications. You may use other books also, but these are some of the books that I am using personally. Now, if we move on to the power plant engineering, let us start with the resources and development of power that is based of the that is the basis of power plant engineering. Now, first we'll start with India. So, in India, the power production started in early 1890s with the first power plant being set up in Darjeeling, that is a hydro station of 200 kilowatt in 1897. Sorry, the first steam power station was also built by the Britishers in 1889. The total generation capacity by the year 1951 was estimated to be around 1710 megawatts. But during its first plan itself, major river valley projects were taken up by the India because the Indian leaders, they understood that the power is the basis for all the development in India or anywhere around, as a matter of fact. So the Bhakra-Nangal, Damodar Valley, Hirakud, Chambal Valley, etc., all were taken up in the first plan itself. During the third plan, they started to integrate all the grids, all the plants into a grid, state in grid, so that all the power could be fed into the main grid, and through that it can be transferred to various sources. Then we have recently seen a very high surge in the renewable energy manifested by the Ministry of New and Renewable Energy Resources. So the Prime Minister is very prominent to or very keen to develop the solar power in India, though he is very keen, and but there are certain aspects that we'll discuss when we'll go into the solar power generation. But now let us move on to understand what is the total power generation capacity of India and what are the various sources through which India is developing these power generation. The sources and everything is being taken from a website which is termed as Power Sector at a Glance All India, Government of India, Ministry of Power. This website is being handled by Ministry of Power. So according to them, the total generation capacity of India is around 3,56,818, out of which around 63.4%, that is around 2,26,279 megawatt, is being generated only by the thermal stations, that is coal, lignite, gas and oil. In that, coal plays the major power player, that is approximated to be around 54.5% of the total power generation. This is the major drawback that we are facing. India is not a very developed country. We cannot afford to spend so much of coal just to generate electricity. We have to utilize it for better resources, and that is why there is more surge in the renewable energy systems. Now, if we move on to the next, the other major power player is the hydroelectric power stations, which is approximated to be around 45,399 megawatt, estimated to be around 12.7% of the total power generation. Nuclear power, we assume that India is a nuclear state, so it may be having a lot of nuclear power generation, but it is approximated to be only 1.9% of the total power generation in India. Though we see a very high power generating capacity of India, but the demand is even higher. So we'll discuss that also. It is approximated to be 6,780 megawatt through nuclear. And renewable energy sources, this renewable energy is approximating around 22%. But why I've listed it and the bottom is because renewable energy sources is not from a single source. There are various sources that too. Even the hydroelectric projects, mini and micro, are also considered into renewables. So they are also considered here. But these are from various sources. The column-gate of these sources are 22%. Now, if we move on to the total generation capacity and the growing trends in India, we can see that around 1,249.33 billion units of electricity is being generated in India. Out of this, almost, according to one of the government agencies in US, they are estimating that the total power generation, total consumption of the world will be around 50 billion units 50,000 billion units by the end of year 2020. So approximately 1% of 10% of it is being utilized by India itself. Now, if we move on to, you can see that the trend is ever increasing, but this is only the generation capacity. If we see the consumption capacity is also increasing at a very higher or faster pace. Now let us understand where India, how much power is being generated through various sources in India and how much power is being utilized in various sectors. So if we go on to this, we see that coal is generating around 838 terawatt hour, and non-utilities are generating 1.186 terawatt hours. Hydro is generating 125 terawatt hours, and natural gas 44, nuclear 87, 84, lignite 34, diesel zero point 0.5, renewable energies as 82. All this power total up to 1337 terawatts. This is the electricity consumption and production in India in 2015. So what we see is, out of this, 367 terawatts hour is lost. This loss, you may see that it's a bigger loss, but this loss is due to the transmission losses and various power losses throughout the country, through the grid, through the transmission losses, through the high tension wires and other things. Now, electricity consumption in India is around 980 terawatt hours, out of which 50% of it is being utilized by the industry, that is 451 terawatt hours. Domestic utilizes 214 terawatt hours, agricultural utilizes 167 terawatt hours, commercially it is being utilized as 86 terawatt hours, others utilize 47 terawatt hours, traction and railways around 15 terawatt hours. So traction and railway itself is around 15 terawatt hours. Now, if we move on to the next, that is steam power plant. Steam power plant, it is the basic, you can say, the schematics of the steam power plant, where you have the various circuits being incorporated in it. We'll discuss about the circuits later. But if we start to think of the steam power plant, the steam power plant will start with the coal pile or a stock pile. The coal is normally stocked in terms of a pile because it reduces the oxidation of the coal. Now from this, the bigger boulders of the coal are being fed into the coal conveyors, and through coal conveyors, it may be your belt conveyor, it may be screw conveyor, various other conveyors. We'll discuss all this when we discuss about the coal handling system. This coal is being passed on to the coal hopper. Through the coal hopper, it is being passed on to the pulverization fuel mill. Pulverization is done because it is easier to burn the coal and efficient also, as well as it reduces the problem of ashes. And this is being fed into the boiler, where it is being burnt to ashes, and the air from in the boiler is converted into flue gases, which is passing on to the flue gas cleaning system through